Greetings, ladies and gentlemen. This is Mark Anderson for Kellogg Community College, and for our second video to review functions, we are going to look at absolute value functions, and then we're going to introduce to you something called interval notation. So we are now going to take a look at these absolute value problems, and we're going to use some tables to help us out here. So we're going to start off first with the absolute value of x, just a simple absolute value equation. And the absolute value means distance from 0. So we're going to see how far things are away from 0. Distance from 0. Now, just an easy way to think of distance from 0 is maybe like a direction. You know, like if it's 5 miles from your house to the mall, it would be still 5 miles from the mall to your house. It wouldn't be a negative 5 miles. We're not doing a vector, which indicates direction. We're just looking at just distance from point A to point B. So with this number line, I'm going to go with -2, -1, 0, 1, and 2. And we're going to plug that value in for x. So -2 in for x, the distance of -2 to 0 is a distance of 2 spaces. So that answer will be 2. So -2, 2. If I plug -1 in for x, the absolute value of -1 is 1. So -1 and 1. 0, plugging that in for x, the distance from 0 to 0 is 0. And then finally, plugging 1 in for x, that gives me a 1. One common mistake is people feel that when they plug in positive numbers for x, they get negative numbers, but that's not true. A positive number is 1 away from that 0, so positive numbers stay positive. And so this gives us a V-like shape. The V-like shape is very distinctive to the absolute value problem itself. I'm going to change colors here because I want to put these all in the same grid. And so now I'm going to look at this graph, and we're going to kind of determine how this is different from the other one. So this is going to be -2, -1, 0, 1, and 2. If I plug -2 in here, I get a +2 plus 7 is going to be 9. If I plug a -1 in there, I get +1 plus 7 is 8. Plug a 0 in there, I get 0 plus 7 is 7. Plugging a 1 in there, 1 stays positive, so 1 plus 7 is back to 8, and 2 plus 7 is up to 9. So here I have my points of -2, 9, -1, 8, 0, 7, 1 and 8, 1 and 9. So there is my beautiful V, and that V right there shows you that this was a vertical shift of 7. We're going to see horizontal and vertical shifts in the next section over, after actually I believe it's section 5 that we're going to be looking at in this chapter. So we're going to see how these addition problems outside of the parentheses or outside of the x versus inside of the x, how does that actually affect what we see? And for this last problem, I'm going to change color one more time. Now, what's going to be interesting is that I'm not actually going to start at -2. I'm going to start here. I'm going to look at that 4 and ask, like, okay, what do I have to do to see where this goes here? Because what I'm going to try is I'm going to try to plug in a -4. If I plug in a -4 into this equation, -4 plus 4 is 0. And the absolute value of 0 is 0. So there's my starting point there. So I'm going to go -5, -6 here. -5 plus 4 is -1. The absolute value of that is 1. -6 plus 4 is -2. The absolute value of that is 2. And then we have -3 and -2. -3 gives me a +1, and -2 gives me a +2. So there is my 1 and 2, and here is my graph here. So let's compare the green V to the blue V and see how it looks. Looks like they're the same shape, it's just that the green V was moved 4 units to the left, so this was a horizontal shift to the left of 4. This up here was a vertical shift of 7. And the more we get familiarized with these before we get to section 5 of this chapter, the better we'll be. So this is our parent function with no shifting at all. This is a vertical shift up 7, and this is a horizontal shift to the left 4. Please note that the vertical shift is exactly the way you would expect it. The +7 moved it up 7. And the horizontal shift is opposite. of what you would think it would be. Instead of moving it right 4, it moved it to the left 4. So for our final part of the video here, we are going to take a look at some graphs here. And I'll have to kind of scroll around a little bit. But these graphs are used to identify intervals where the function is increasing, decreasing, or constant. Now, so we don't have to write out as much, let me first of all change back to blue. I could keep it at green, but I am not going to. Increasing, I'm going to use an up arrow for increasing, down arrow for decreasing, and a right arrow for constant. And we're going to learn something about interval notation here. Now, I'm looking at this segment, and this curvy segment here starts here at -4 on my x. So we're going to look at my x, since we're talking about finding the domain, and we're going to use our x values here to kind of tell us where we increase, decrease, or flatten out. And this graph increases from all the way from the left of -4 all the way to the right of 3. So I will use the up arrow to show me on my homework this is increasing, and I'm going to use set notation here to kind of compare and contrast interval notation. This goes from -4 to 3, and in the set notation, x is between these values. And since we can actually have a dot at -4 and a dot at 3, then these have to be less than or equal to symbols, because x is greater than or equal to -4 and x is less than or equal to 3. Now, in terms of interval notation, let's talk about how we would do that. The number on the very left of our domain is going to be -4. The number on the very right of our domain is going to be 3. There's a comma between the two of them. That's to show that we're going from -4 to 3. And since we can actually land on that -4 and we can land on that 3, we can use a bracket here and a bracket here. We would use parentheses if these were open circles or if we were going to infinity, but we're going to use brackets right there. Now let's take a look at this graph below it. This graph definitely decreases and then increases. So it decreases from -4 to 2. So what we're going to use is the interval notation of -4, -2. And we'll use these hard brackets because it actually connects to these points and locations. And then it increases from 2 all the way up to 4. 2, 4. Whoops. And this should be a hard bracket as well. And it's a hard bracket because it it can touch that dot right there at 4. Now, we have to be a little bit more careful when we have infinities, because you can see that this graph is going up from this -infinity all the way up to 2 on my x value. So on the left-hand side, this would be -infinity. As we have this interval notation, we would go from -infinity all the way up to this +2. Now you'll note that I have a curvy line here, and the curvy line denotes that this is something I can never actually get to. So -infinity just shows you or denotes the fact that, yep, I'm going to be all the way to the left here, and I would not use a bracket ever for any kind of infinity. Now we're going to be decreasing from that moment of 2 all the way to +infinity. And we would use a parenthesis here to show that, hey, we're going to be never getting to that +infinity on the right-hand side. So brackets are only for when we actually connect 2 points. Now here we have some constant spots here, and this goes from -infinity to 0 on my x-axis. So we're going to have a parenthesis, -infinity, 0, bracket. Then it's going to decrease from 0 to 3, because this looks like about 3 on the x-axis, and we'll put a bracket there. But then we're going to have another flat spot from 3 all the way to +infinity. So here's a bracket on 3, +infinity, and we have another parenthesis there. And we can use the union symbol here to show you that it's either this or this over here to the right. So here we have the use of our union symbol for interval notation. Now, be careful not to use the and symbol, the upside down U, because that would mean it would be the intersection of these two rays, and there are no intersections there. So for our final two problems for this worksheet here, let's take a look at a situation where we have a line that is increasing all the way from the left to the right. Now it's increasing even though that's a downwards arrow, because we always look at graphs from the left to the right. So this is increasing from negative infinity to positive infinity, because it's just going to keep going and keep getting wider and wider. So this is how you would write all real numbers in interval notation, from negative infinity to positive infinity. So for this final, you may want to pause the video and see if you can do this yourself. So, pause now, write down when it's increasing and when it's decreasing and what the symbols look like. So it is increasing from negative infinity to 2. So here we go, negative infinity, comma 2, with a bracket on that because it can actually touch 2. And then here it is going to be decreasing from decreasing from 2 to positive infinity. And again, using parentheses when there would be either an open circle or infinity, and closed and a bracket, beautiful bracket when you have a closed dot or something it could actually touch. Well, thank you very much for watching this video. This has been part 2 of this review of functions, and I hope you found it informative. Thanks for watching.